Hi students. Today we're going to learn about common factors. Go ahead and write the title on your notes before you start. Remember, our unit learning goal is how to have patterns help me find factors and multiples. For this lesson, we're going to focus on how can you tell if one number is a factor of the other, specifically focusing on factors that numbers have in common. Take this problem, for example. Chuck has a coin collection with 30 pennies, 24 quarters, and 36 nickels. He wants to arrange the coins into rows. Each row will have the same number of coins, and all the coins in a row will be the same. How many coins can he put in each row? Common factors can help us solve this problem. Common factors are simply factors that are the same with two or more numbers. To solve this problem, I'm going to use the information about Chuck's coin collection. I know he has 30 pennies, 24 quarters, and 36 nickels. What Chuck is trying to do is arrange his coins into equal rows. And he wants them to have the same number in each row and the same type of coin. So, in order to do that, I need the numbers 30, 24, and 36 to be split in a way that each one can have the same number in each row. I'm going to find this answer by finding the common factors for 30, 24, and 36. Let's start by listing the factors of 30. I know that 1 times 30 is 30. 30 ends in 0, so it's even. 2 is also a factor. And half of 30 is 15. So 2 times 15 is 30. 30 is also has 3 as a factor, because 3 times 10 is 30. Now, 4 is not a factor of 30, even though it's an even number, because 4 times 7 is 28, and 4 times 8 is 32. 5 is also a factor of 30, because it ends in a 0, and 5 times 6 is 30. The next number I would list would be 6 times 5, but since 6 is already there, I know I'm done, and I've listed all my factors of 30. Now I'm going to list the factors of 24 to represent the 24 quarters. Of course, I start with 1 and 24. 24 is even, so 2 is a factor, and half of 24 is 12. 2 plus 4 is 6. So 3 is also a factor of 24. As a matter of fact, 3 times 8 is 24. Since 2 and 3 are factors of 24, I know that 6 is also a factor of 24. And in this case, 4 times 6 equals 24. 5 is not a factor of 24, and since the next number I would get to by counting is 6 and it's already there, I know that I've listed all my factors for 24. Finally, I'm going to list the factors for 36. 1 times 36, and 36 is even, so 2 is a factor of 36. Half of 36 is 18. So 2 times 18 is 36. 3 plus 6 is 9. So I know that 36 is a factor of 3. I know that 3 times 10 is 30, which make 3 times 11 33. So 3 times 12 is 36. I know from my multiplication facts that 4 is a factor of 36 as well, since 4 times 9 is 36. 5 is not a factor of 36 because it ends in a 6, not a 0 or a 5. But 6 is 6 times 6 is 36. Now that I've listed all the factors of 30, 24, and 36, to find how many rows of the same coin and the same amount that Chuck can put his coins into, I'm going to look for the common factors. Of course, 1 is a common factor with all of these numbers. So is 2. 3 is in all of the numbers as factors as well. But 4 is not. 5 also is not. 6 is. 10, 8, or 9 are not. Neither is 15, 12, or any of the remaining factors. So the common factors are 1, 2, 3, and 6. This tells me that Chuck can either put 1 coin in each row, 2 coins in each row, 3 coins in each row, or 6 coins in each row. Let's try another problem. Go ahead and copy this problem into your notes so you have it for an example. Ryan collects animal figures. He has 45 elephants, 36 zebras, and 18 tigers. He will arrange the figures into rows. Each row will have the same number of figures, and all the figures in a row will be the same. How many figures can be in each row? Like the last problem, we're trying to arrange something into equal rows where all the figures are the same. I see that Ryan has 45 elephant figures, 36 zebra figures, and 18 tiger figures. So to solve this problem, I'm going to find the factors for 45, 36, and 18 and see which numbers they have in common. Starting with 45, of course, there's 1 and 45. What about 2? 45 is not even, so 2 is not a factor. What about 3? If I do 4 plus 5, I get 9. That means that 3 must be a factor of 45. I know that 3 times 10 is 30. And 3 times 11 then would be 33. I'm going to count up by 3s from 30 until I get to 45. 30, 33, 36, 39, 42, 45. Since I know that 3 times 10 is 30, this would be 3 times 11, 3 times 12, 3 times 13, 3 times 14, and 3 times 15. So 3 times 15 is 45. 4, well, 45's not even, so 4 should not be a factor of 45. I can also say that I know that 4 times 10 is 40, and 4 times 11 would then be 44. So 4 won't work. But 45 does end in a 5, so 5 is a factor, and 5 times 9 is 45. Since 2 and 3 were not factors of 45, I know it's not a 6. And I know that 7 times 7 is 49, so 7 won't work either. I know that 8 times 5 is 40, so 8 isn't a factor either. And then I get to 9, which is already there, so I can say I've listed all my factors. Try 36 and 18 on your own, and then pause the video to see if you correctly listed all the factors for 36 and 18. For 36, did you get 1 and 36? How about 2 and 18. Three and 12, 4 and 9, and 6 times 6. For 18, did you get 1 times 18? 2 times 9? 3 times 6? And then you're done. Now look for the common factors that these three numbers have in common. Of course, 1. I see 3 in each row as well. I also see 9. And those are all the factors that all three numbers have in common, telling me that my answer is that they can have either 1, 3, or 9 figures in each row. Let's do one more example together, just to make sure you really understand how we're finding these numbers. Remember, when finding factors, I'm thinking about all my divisibility rules and my multiplication facts. Lucy has 40 bean plants, 32 tomato plants, and 16 pepper plants. She wants to put the plants in rows, with only one type of plant in each row. All the rows will have the same number of plants. How many plants can Lucy put in each row? Again, I see rows with equal numbers and the same type for 3 different numbers. So I'm going to do factors of 40, 32, and 16 and look for what they have in common. 40 is 1 and 40, 2 and 20, but not 3. 4 times 10, and 5 times 8. 6 and 7 are not factors of 40, and 8's already there, so I know I've listed all the factors of 40. For 32, I have 1 and 32. 2 and 16. Not 3, but 4 times 8. And not 5, or 6, or 7. And since 8's there, again I know I've listed all my factors. For 16, I have 1 and 16, and 2 times 8, not 3, but 4 times 4. And since 4 is a doubles fact, I know I've listed all the factors for 16. Looking for my common factors, I see 1, 2, 4, and 8. That gives me the answer that Lucy can plant her plants in either rows of 1, 2, 4, or 8. Think about these problems. What was similar about each of them? When problems are asking you to find factors, your answers are always smaller than your number. The other part, when word problems are asking you about factors, is that typically they're wanting to either arrange something into rows and do it evenly, or put something into packages or buy packages evenly for a certain amount. So if they're arranging something into rows or packages for equal amounts, that's usually a trick to tell you that it's factors or as well. Write this information down because it's important to know how to decide if the problem is asking you to find factors, and it will become more important as we go into the later lessons in this chapter. All right, it's time for your check. Go ahead and complete the check that goes with the lesson, and we'll review these problems tomorrow in class. Have a great night.